let us discuss the problems based on the conversion of inverse trigonometric function into its simplest form. While converting the inverse trigonometric function into its simplest form, we require to remember the substitutions, multiple angle formulas and half angles, that is submultiple angles. So let us write the substitutions, multiple angles and also as well as submultiple angles. So after knowing all this, let us go for discussing the problems in simplifying the inverse trigonometric function into its simplest form. So first let us know the multiple angles. Multiple angles. So as we know that multiple angles, suppose if we have theta, if we multiply by 2 theta, 2, then it becomes 2 theta. If we multiply by 3, it will become 3 theta. So like that, so we can observe the formulas in multiple angles. But in second standard we observe, so in CBSE 2 or class 12, so we observe the formulas up to sine of 3 theta. Suppose if it exceeds 3 theta, then we consider the concept of compound angles. So let us write the formulas of sine 2 theta. There are two formulas we have for sine of 2 theta. The first one is sine 2 theta can be written in terms of sine and cos, and the formula is 2 sine theta into cos of theta. Second one is we consider sine 2 theta in terms of tan theta as 2 tan theta divided by 1 plus of tan square of theta. So remember that in the denominator we require to write plus. Suppose if we write minus, it is the formula for tan of 2 theta. So now let us discuss the formulas related to cos of 2 theta. So when we consider cos of 2 theta, we have 4 formulas for cos of 2 theta. First one we can consider in terms of cos theta and sin theta, that we will write as cos square theta minus sin square of theta. Now the second one is 1 minus 2 sin square theta, that is we express cos 2 theta purely in terms of sine function and can be written as 1 minus 2 sin square of theta. Similarly, the third one is 2 cos square of theta minus of 1. So whenever we observe the term 1 minus 2x square, it is, we require to remember that x can be substituted as sine of theta. So whenever we observe the term 2x square minus 1, so x can be replaced as cos of theta. Now we express cos 2 theta in terms of tan theta as 1 minus tan square of theta divided by 1 plus of tan square of theta. That is, whenever we observe 1 minus x square divided by 1 plus x square, we can replace the value of x as tan of theta. So these are the formulas we have for sine 2 theta and cos 2 theta. So let us consider the last one, that is tan of 2 theta. We have only one formula for tan of 2 theta and can be considered as 2 tan theta divided by 1 plus tan square of theta. So these are the formulas we have for 2 theta. Let us observe the formula for 3 theta. Sine of 3 theta. Sine of 3 theta can be written as 3 sine theta minus 4 sine cube of theta. So this is the formula we have for sine of 3 theta. Similarly, cos of 3 theta. The formula for cos of 3 theta will be, so 4 cos cube theta minus 3 cos of theta. Similarly, for tan of 3 theta, so we consider 3 tan theta. Suppose if you don't know the method of writing the formula for tan 3 theta, write the given term in this format, tan of a plus b, which can be considered as tan a plus tan b divided by 1 minus tan a into tan of b. Now I write this term 3 theta as 2 theta plus theta. So 2 theta plus theta will be 3 theta, and I used to write this term as tan 2 theta plus tan of theta whole divided by 1 minus tan 2 theta into tan of theta. And let us replace the value of tan of 2 theta as 2 tan theta divided by 1 plus of tan square of theta plus tan of theta divided by 1 minus, so we can replace tan 2 theta as 2 tan theta divided by 1 minus tan square of theta into tan of theta. So remember that in case of tan 2 theta we require to write in the denominator as minus. Suppose if we write plus, that is the formula we have for sin of 2 theta. So let us check what happens if we consider the LCM as 1 minus tan square. If we consider 1 minus tan square theta as LCM in the numerator, the term takes the form of 2 tan theta plus tan theta into 1 is tan theta minus tan cube of theta whole divided by, once again we have 1 minus tan square theta as LCM in the denominator. So therefore 1 minus tan square of theta, as we have considered 1 minus tan square theta as LCM, 1 minus tan square theta minus 2 tan theta into tan theta will be 2 tan square of theta. 1 minus tan square theta, both in numerator and denominator, that get cancels, which will be equals to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square of theta. So this is how we used to write the formula for tan of 3 theta, by considering the compound angle formula in terms of tan theta. So therefore we write 3 tan theta minus tan cube theta divided by 1 minus 3 tan square of theta. That is, whenever if the problem is of the form 3x minus x cube divided by 1 minus 3x square, it implies that we need to consider the value of x as tan of theta. So these are the formulas we used to observe in case of multiple angles. Now let us consider the half angles. So what are half angles? As we have discussed in the previous problems, that one can be written as cos square theta by 2 plus sin square of theta by 2. This is the first formula we need to remember. And then sin theta can be written as 2 sin theta by 2 into cos of theta by 2. Whenever if in a problem we observe the term 1 and sin theta, suppose if we require to prove theta by 2 towards right side, so we need to replace the following formulas. One can be considered in terms of half angles as cos square theta by 2 plus sin square theta by 2, and then sin theta can be written in terms of half angles as 2 sin theta by 2 into cos of theta by 2. Now let us observe the third one, 1 plus cos theta. So whenever we have 1 plus cos theta, its value will be 2 cos square theta by 2. Now 1 minus cos theta. So whenever we have 1 minus cos theta, we can consider this in terms of sin and can be written as 1 minus cos theta can be written as 2 sin square theta by 2. So these are the substitutions or the formulas we used to consider in case of half angles. Okay. Now let us observe the substitutions we used to observe in the inverse trigonometric function when we simplify the inverse trigonometric functions. 1 plus x square, which implies x can be considered as tan of theta. And then 1 minus x square. So the substitution for x will be sine of theta. So whenever we observe x square minus of 1, so which implies the value of x will be secant of theta. So these are the terms we consider from the standard identities. Suppose if we have a square plus x square, so the substitution x can be considered as x is equals to a tan of theta. Suppose we have a square minus x square, then x can be considered as a sine of theta. So whenever we have x square minus a square, the substitution can be considered as a secant of theta. So as we have observed, whenever we have 1 minus 2x square or 2x square minus of 1, so the substitution for this will be x will be sine of theta. So 2x square minus 1, in case of this, so we consider x as cos of theta. And so whenever we have 1 plus of tan of x divided by 1 minus of tan of x, it implies that, but we need to consider this term 1 as a tan of pi by 4 plus tan of x divided by 1 minus 1 can be considered as tan pi by 4 into tan of x, and the value can be considered as tan of pi by 4 plus x. So this is the point we require to remember whenever we are discussing the simplest form, that is conversion of inverse trigonometric function into its simplest form. See here, the question is we require to write tan inverse of root of 1 plus x square minus of 1 divided by x in its simplest form. So as we have observed that whenever we observe 1 plus x square, put x is equals to tan of theta. This is what we have just now observed. Whenever we have 1 plus x square, so it is a point to remember that x can be considered as tan of theta. So therefore the value of theta will be tan inverse of x. So now I will consider the given problem, tan inverse of root of 1 plus x square minus 1 divided by x. We have this. So I will replace the value of x as tan theta. Therefore it takes square root of 1 plus tan square theta minus of 1 divided by tan of theta. So as we know that 1 plus tan square can be considered as a secant square of theta minus of 1 divided by tan of theta. Now cancelling square and square root. So we have tan inverse of secant theta. Secant theta can be written as 1 divided by cos theta minus of 1 divided by tan theta can be considered as sin theta divided by cos theta. So remember that secant theta can be considered as 1 divided by cos theta, as it is a reciprocal trigonometric function, and tan theta can be considered as sin theta divided by cos of theta. So now, tan inverse of cos theta will be LCM. So therefore we will write 1 minus cos of theta whole divided by sin theta divided by cos of theta. Now cos theta, the term that get cancels, which is equals to tan inverse of 1 minus cos theta can be considered as 2 sin square theta by 2, and this term sin theta can be considered as 2 sin theta by 2 into cos of theta divided by 2. Now cancel 2 and 2, sin theta by 2 and sin theta by 2. So we observe that tan inverse of sin by cos is nothing but tan of theta divided by 2. So which is equals to theta divided by 2. So this theta we have considered as tan inverse of x. Therefore, half into the value of theta in this case will be tan inverse of x. Therefore, the simplified value of this problem will be half into tan inverse of x.